Hello everyone, welcome to my YouTube channel Ardent Flower. Today we will be discussing about a question asked in Neet examination 2022. So first let us read the question. In an E. coli strain, I gene gets mutated and its product cannot bind the inducer molecule. If growth medium is provided with lactose, what will be the outcome? So before solving the question, first let us understand the lactose operon. We all know that the lactose operon has three structural genes: LAC-Z, LAC-Y, and A. There is an operator, promoter, inhibitor gene, and a promoter. So, this promoter is for the inhibitor gene, and all the three structural genes are under control of a single promoter. So, therefore, in prokaryotes are generally known as polycystronic, where several genes are under control of a single promoter. Now, basically, first, what is a gene? A gene is a segment of DNA that codes for a functional protein. Now, here, LAC, Z, Y, and A genes, A are structural genes, as I said. What do I mean by structural genes? These are the genes which encode for a protein. Now, LAC Z gene encodes for beta galactosidase enzyme. LAC Y gene encodes for permease, and LAC A gene encodes for transacetylase. While I gene is known as the regulatory gene. What is a regulatory gene? Those genes which whose products control the expression of structural genes are known as regulatory genes. Now, I gene means it also codes for a protein. So it codes for a repressor molecule, which is a homotetramer, means it is made up of four identical units. Now, when let us understand what is the ideal situation of this operon when lactose is absent. So, in the medium, lactose is absent. So, what's the situation? So, we know that three structural genes, there's an operator, promoter, inhibitor, and a promoter. So this is how the operon is present. Now I gene encodes for the repressor molecule. This repressor molecule has a very high affinity to bind to a very specific sequence in the operon, which is the operator sequence. So it goes and binds in the operator sequence. Now we know that promoter is a sequence in the DNA where RNA polymerase comes and binds. So this is your RNA polymerase. Now RNA polymerase binds to the promoter region, but it cannot move as there is a hindrance or obstacle for it. Therefore, there is no transcription of Z, Y, and A genes. So there will be no transcription. So when lactose is not provided in the medium, when lactose is absent, basically the operon will be off. This is the ideal condition. Now let us consider a situation where lactose is provided in the medium. Now we know that, again I'm drawing the operon where we have the three structural genes LAC-Z, Y, and A. You have the operator, promoter, inhibitor, which is the regulatory gene. Now here, as usual, the inhibitor gene encodes for the repressor molecule, but here, as I told you, lactose is provided in the medium. Now this lactose molecule, it binds to the repressor molecule such that it changes its conformation, as a result of which now the repressor molecule cannot bind to the operator region. As a result, what will happen? Since the operator region is free, we know that RNA polymerase binds to the promoter region. It can freely move. Thus, there will be transcription taking place, and the genes get translated. So when lactose is provided in the medium, the operon is on. So this is the ideal situation. Now let's come back to the question. In an E. coli strain, I gene gets mutated. Now again I'm drawing the operon so that we can clearly understand. Z by A gene, there's an operator, promoter, regulatory gene I, and a promoter for the regulatory gene. Now this I gene is mutated. I gene got mutated such that the I gene codes for a repressor molecule. This repressor molecule, even though we provided lactose in the medium, they said that lactose is provided in the medium. Though lactose is provided, the repressor molecule is unable to bind to the lactose molecule. So what happens in that situation? Now the repressor molecule has an affinity to bind to the operator region. So the repressor molecule binds to the operator region as usual, and we know that RNA polymerase binds to a specific segment in the DNA molecule known as the promoter. Now, RNA polymerase binds to the promoter region, but still, due to the hindrance or due to the obstacle of the repressor molecule binding to the operator region, the RNA polymerase cannot move forward. So, there will not be any transcription occurring, no transcription. Though lactose is provided in the medium, but still, since there is a mutation in the I gene, the product repressor molecule is unable to bind to lactose. So, what happened? The repressor molecule has affinity to the operator region, so it binds to the operator region, not allowing RNA polymerase to move, no transcription, and no translation occurring. Now, let us read the options. If growth medium is provided with lactose, what will be the outcome? What's the final outcome? RNA polymerase will bind the promoter region. This occurs even when the mutation is not occurring or whether it occurs. Only Z gene will get transcribed. There is no chance of transcription of any of the three genes. So this option will be incorrect. ZYA genes will be transcribed. No, because the RNA polymerase is unable to move forward. There is no chance of transcription to occur. ZYA genes will not be translated. This is true. Since there is no transcription, there will not be any translation occurring. So the fourth option is correct. So the final outcome of this event is Z, Y, and A genes will not be translated. Hope you understood the answer for this question. And if you like the content of this video, please like, subscribe my channel, and share it with your friends so that they can get benefited. Thank you.